Welcome back to Developers Home, and today we are discussing about Spark ETL with Lakehouse. And in Lakehouse we are doing this Spark ETL with Apache HUDI. In earlier blog and video we have discussed Spark ETL with Lakehouse, and that is with Delta Lake. So today we are discussing with Apache HUDI, and in the next video and blog we are discussing with Apache Iceberg. So in a way we are covering all the famous data lake formats, which are data lake and then Apache HUDI and Apache Iceberg. So now before going to actual ETL, what we will do is we'll first understand what is Apache HUDI. So basically Apache HUDI stands for Hadoop Upsert Deletes and Increments. This is open source project, but it is actually developed by Uber and then it was contributed to Apache Software Foundation. So now it's an open source project, and there are very big companies, they are now creating their lakehouse using Apache HUDI. So as an example, let's say Uber, Alibaba, Verizon Media, and there are few big companies, they are using Apache HUDI as their lakehouse format. So we'll understand that what are the advantages and what are the key features Apache HUDI provides. So first thing is, it's very easy to do upsert, delete and increment with Apache HUDI. So it's very efficient doing updates, deletes in existing data which is stored in a Hadoop based data lake. Transactional writes, so it is having ACID transactions, so it ensures that data is consistent and reliable. And then delta storage, so HUDI is using delta format for storing data. So that we understood in a last video and blog that delta is using Parquet plus metadata to store this all data, and now HUDI is designed on top of delta. So here we'll also see that how it's storing data and metadata, and that is also Parquet format, and it's also creating separate metadata files. Schema evolution, so that earlier days when that if you are making any change in a schema or if you want to delete any data, so what we were doing is we were reading all the data from Parquet and then creating one more folder storing everything again there. So which is like that reading all the data again, processing and then inserting again. So with this that schema evolution, that you can on the go reload this data and you can change schema without reloading this data. Data indexing, it is also giving a way that we can create indexes, and then using indexes we can improve this data read operations. Same way in Delta Lake, that there are Z order and partitioning, those all functions are available. Same way with Apache HUDI, these are the functions available with different concepts which we'll discuss in a separate blog. But for now we'll go to ETL, and in ETL what we are doing is that always we are taking one source system and one destination. As a destination today we are considering Apache HUDI, but as a source we are taking MySQL, and we have one table created into MySQL database, and then we read data from there, we do transformation and then load data into Apache HUDI format. So if you have followed earlier blog and video, we have taken same source MySQL, we were reading data from there and then we are inserting into Delta Lake. So now we are doing same with HUDI. So if you followed earlier video, you can just skip this first two part and you can go to this third part. I'm also not covering that much in detail about this first two part because we all know how to read data from MySQL and create Hive table and then create data frame from that. So before that, what you can do is you can go to this Github Repo, you can clone that, so that you can also practice on this same setup. If you don't have Spark instance setup, MySQL instance setup, you can follow earlier videos and blog and you can create your own environment in your local laptop. You're using Mac, Ubuntu or Windows. It's easy to set up using Docker, so you can follow earlier blogs and you can set up same environment into your system also. So now I am going to Jupyter Lab and starting all this Spark ETL processes. So we are currently in chapter 8. Before starting that we first need to understand what are the external packages required to start this Apache Spark application and sessions. So we know that here we are dealing with Apache HUDI and MySQL. So if in case with our Spark instance, we don't have those packages installed, we need to specify that we need these packages to start our Spark session. And in our case, we are dealing with HUDI and MySQL, and that's why in Spark jar packages, I am specifying that I need HUDI and I need MySQL. So what it will do is it will go to Meduim Repo, download those packages and install those packages for us. So we are specifying these two packages here. And with HUDI, when you start Spark session, we also need to specify few configurations. So these are the configurations we need to pass. If you go here, you will also get to know that we are passing these 4 configurations with starting our Spark session. So now what I will do is I will start this Spark session and we'll see that it will download all the required packages and start Spark session with our required configuration. So now if you go here, we see that it's getting Apache HUDI and it's also getting MySQL, and now we have already downloaded those packages earlier, and that's why it says that everything is here and now our Spark session is ready to use. So first thing is, that what we have done earlier, I am just creating data frame from MySQL. So let's just quickly create data frame which reads data from our table, and our table which is having like these are the columns: food name, scientific food name, group and subgroup. So now we have data loaded into data frame, just checking schema, just displaying data from data frame. So we'll be sure that we have data in our data frame. Next step is create Hive temp view so that we can write Spark SQLs, and here that is also created. We'll just do simple Spark SQL query. So we'll get to know that our temp table is having data. And now, so we have source our data. Next thing is transformation. And just for transformation, what we do is we just analyze data. We just want to see that by group, how many rows we have. So we are executing that query. And after that, what we will do is we create one more data frame. And in that data frame, we'll only store one group type of data. So now what I am doing here is I am just filtering those data with only one group, which is herbs and spice. So now that is done, and we'll just check how many rows in there. So I see there are 52 rows, and now I will just for now comment this one and we'll use this one. So in the next step, what we will do is we have source data, we have transformed that, and now we load that data into Apache HUDI format. So earlier we have stored this data into Delta format, CSV, JSON, ORC, Parquet, and we know syntax for that is a data frame dot write dot format dot mode and dot save. So same format here we are using, only difference is in a format we are passing HUDI. And you know that we were also passing options, like in case of JSON, let's say we need multi-line JSON, single line JSON. In case of CSV, what is a separator? Is it like comma, pipeline? So we were doing that same way with HUDI also. We will be passing few options, but here with HUDI, there are few mandatory options which we have to pass. If we don't pass, it will not create HUDI table. So we understand what are the mandatory options we need to pass. First thing is what is the HUDI table name. So we are saying that our table name is HUDI underscore food, and then we need to pass what is a unique column or record key in our table. So here you know that what we have in a unique is a food name, and that's why we are passing that food name is our unique. Normally when we have a table, in that table you know that we have auto increment ID or sometime combination of few column which is also unique. So we can also pass that if in case we have combination of food name and sub food name or group which is always unique, so we can also use that. But in our case today we have food name as a unique, and that's why I am just passing food name. And then pre-combined full field, in that we need to pass something like timestamp, and that's why you know that in earlier like syntax where I have created new data frame, you see that I have added a now, which will give current timestamp, and I'm just saying that as a timestamp. So that's what I am passing here. If you don't pass, it will by default consider that we have TS as our timestamp. So as of now, I am just going with mandatory fields, so which is table name and record key. And then I'm saying that I want to create this file into this folder, which is base path. So now if I'll execute this, it will create HUDI table using this data frame. So I'm just executing this now, which is executing, and it's creating this HUDI table in a background. So this is still executing. So now and this is actually running on port number 4040. So we can also go to port number 4040 and we can check it from there. But now if you see here, we have this HUDI food. So basically we have given that we want this all data into this folder. So it's created one folder, and what we see is it created one Parquet file. But where are this metadata? We can't see metadata from here, from Jupyter Lab, because you know that if you go now how it creates this file. So it's normally creates file in this way. This is our base path, and then it create one meta path. So it create one folder which is like .hudi, and that's why we can't able to see it from Jupyter Lab, but we'll go into Spark instance and we'll check it from there also. And then it will create hudi.properties, which will be inside HUDI folder, where it will store all the properties of HUDI table, and then it will create one metadata table folder, and in that it will store all the metadata of our table. And this is data.parquet, which we can see it from here, which stores actual data. So we have, you know, that one which is like storing data and one which is storing metadata. So now if I simply go from here, opt spark, and then I think we have Spark ETL. We are currently in chapter 8. So now is a directory. So I just need to pass this way, Spark ETL chapter 8. And now if I do this one, we have HUDI food. So I will go inside HUDI food. And now if I do LSL, it will only show us Parquet file. But if I say that I also want to have hidden files, so if I do this one, it will show now that we have this HUDI folder, and which actually stores this all data. These are the just cache which it stored. So now so basically we have two folders which is important. One is HUDI and one is actual data. So now if I go inside HUDI, and now if I do LSL, so here we have HUDI properties, which stores all the properties of our table. So you know that what are the properties we have passed. It will store everything. What is the table name, what is a record key field. So these are the all, you know, that by default format is Parquet, and that's why it says that Parquet is a folder. We haven't given database name, so it's not storing that. So this is the property which store hudi.properties file. And now if we go inside metadata folder, and we'll see that this is actually storing our metadata. And now if I go inside, so basically this stores our metadata. So now you know that we have created our first HUDI table. But now what we want to do is I will first, you know, that what I will do is I will just go outside of this one, and actually I just want to delete this folder. And so now we are at so now we are at this level. And now what I want to do is I will drop this table, and so what I am just doing is I am deleting this now. And second time what we will do is we'll use more properties, so which is not mandatory, but still we'll pass that. And this time you see that we are saying that our partition path is group, because we just also want to understand that what if in case we are passing all the properties. So we are saying that we want to partition this data based on a group. because here we see that we have that group and then we have subgroup. We can also do at subgroup level, we can also do at group level. So I'm just saying that we want to partition this data at group level, and then we are saying that data source write operation upsort. If in case we are passing same data again, we don't want to insert that, but based on key ID we want to upsort, so it will upsort. So it's actually really easy, that in case of like SQL server we need to like check, okay, update or insert, but here that by default we are having these operations which that compare key, and then if it's upsort it will directly do upsort, which is really good. And we all also want to do insert and upsort at that parallelism of 2. So now we'll execute same thing and it will create same table again, but now that we will see one more folder and we'll see that the actual data inside that folder. So now it has already created this table. If I go inside, so that earlier when we went inside we were directly seeing that Parquet file here, but now onwards what it will do is it will partition by group, so it will store inside this herbs and spice. So same way, if we go here into our instance, and now if I go here inside, so what we will see is we have this HUDI here and then we have this folder. So now if I go here, so now inside this we have actual Parquet file which stores data. So that if you also want to use partition, you can also just specify here and it will create partition. So now next thing is we have that stored this data, we have created our initial table. Next thing is we will append data, and now I am using same HUDI option, so it will follow this one. And when I do insert, so this time we have used fruits as our group, and now it will create one more folder there. So now if I do this one, it will create one more folder and it will store all data into that folder. So now if you go inside, we have one folder which is fruit. In that we have all the data for fruit, and we have one folder which is herbs and spice. So in that folder we have all data for that. So this is how that we can create our HUDI table and insert update data. Next thing is, so our ETL is complete now, but now we'll also understand how to read data from HUDI. So it's the same thing we always do, spark.read.format and then load. Here we are passing HUDI as our format. So if I execute this one, I will have this all my data into HUDI data frame, and now I will execute this one and I see that there are 5 columns which are extra, which we haven't created. We have like food, scientific name, subgroup, group and timestamp which we have created, but we see this 5 extra columns. So what are those 5 extra columns? So these are actual metadata created by HUDI. So if you want to understand that, so what is HUDI commit time? So it's actually storing that timestamp when this data is created, and then we have commit sequence number, which is actually sequence number in which this commit happened, record key which we have passed, in our case food name will be there, partition path, so which data is stored in which location, and file name, so in which file which data is stored. So that way we have this metadata is created by default by HUDI. So now we'll create temp table on top of this data frame, and now we will actually see this data, and we will see this that we have executed this one, and now we see that here it's storing first commit time, which is like 2023 03, which is month, 23 which is date, and then this is time which is like 22 58 64 16 which is second, and this is millisecond. Same way we have sequence number and then a record key. So this is our record key which is food name, and then partition path and then actual file name. So what we will do is, just to understand few things, we'll also display one more thing here, and now we'll be only interested in these are the columns. So we'll actually understand what are the values are stored. because we don't see that from here, and that's why I'm planning that we'll separately see those values. So here if I just want to display these two things, so that we will understand what are the actual values we have for those. So now, oh okay, so let's do this way. Truncate is equal to false, so it will not truncate values. And here we see that, so here we have actual timestamp plus sequence, which is 0 1 2 3 4, so in which sequence this data is committed. So this is how you know that it stores data. So now if in case, so after that what we are doing is we are just exploring Spark SQL and writing different queries with Apache HUDI. So this is just giving that number of counts, what are the distinct subgroup, and we want to get number of rows based on subgroup. So yeah, this is how we also explore data. So at the end, you know that today with Apache HUDI, we have learned like what is actually Apache HUDI, how it stores data, how can we install packages for that, how can we configure parameters for Apache HUDI, how to create initial table and load data, how to give config properties so it can create like partition or it can create different metadata based on that, how to store data in which format, and how to do Spark SQL queries on top of HUDI. So this is what we have learned today. But you know that if you want to also practice this, what you can do is you can clone this Github Repo and you can also execute same code, and you'll also learn how to create Apache HUDI table. And if you want to learn more on Spark ETL, you can follow developershome.blog as a website, or you can go to this medium.com/developershome, and here we have one list created where you know that all the ETLs which we have done till now, you can understand from there. We are also doing all other data engineering, you know that problem solving and learning about data engineering. So you can go here and you can also check it from there. You can also check this YouTube video, which is like developers home, which is youtube.com/developers home in, and from there also you know that we have this all the playlists created. This is for Spark ETL pipeline, solving data engineering problems, Docker container, or IoT system design. So you can also go through with that. And if you have any questions, you can comment on Medium, YouTube, or in blog, and we can discuss on more. So yeah, thanks for watching, and we'll see you in the next video.